Okay. What is electricity? Electricity means it's a branch of physics. Okay. Electricity is a branch of physics because physics has many branches: optics, kinematics, dynamics, and so on. Semiconductor, electronics, and so on. But electricity is nothing but it's a branch of physics which deals with the charges and its properties. Okay.
Yeah.
Charges and its properties. So in this class, we'll be mainly studying about the symbols, the circuit symbols. What do you mean by current? What do you mean by voltage, and so on? Okay. Okay, fine. So first and foremost, what is a circuit? Circuit is nothing but it's a combination of the electrical apparatus. Okay. So what are those apparatus include? I'm just giving a rough diagram. First and foremost is cell. Okay, this is a cell.
Yeah.
What is a cell? Cell is a device which converts chemical energy into electrical
energy.
Chemical energy to electrical energy. So inside this are the chemical. So from positive to negative, chemical energy is converted into electrical energy. This is the symbol. Okay. Next, battery. What is a battery? Battery is nothing but a group of 2 or more cells. Battery is a combination of 2 or more cells. Okay, if you connect 2 cells next to each other, then it is called as a battery. So this is a symbol for a battery. Always keep one thing in your mind: the symbols are very, very important. Because these are the basis which you will use in order to solve the resistor numericals as well in your AS and A levels.
Okay.
Next, what is voltmeter? What is voltmeter? Voltmeter is a device. Okay, it's a device which measures voltage or potential difference. Because I'll tell you what is voltage, what is potential difference, how does it differ from each other. Next is what? Ammeter. Ammeter is, this is the symbol for ammeter. Ammeter is a device which measures current. Okay. Because you need something to measure, right? How much voltage, how much current is flowing. That is an ammeter.
Yeah.
Understanding? Okay. Next, drawing a circuit symbol. So while you're drawing a circuit symbol, so always it should have a DC source. DC means direct current.
Okay.
Direct current. What is direct current? What is alternating current? That is a high electrical concepts. Okay.
Okay.
This is a battery. Next. Okay, fine. How does the and these lines are wire or the conductor?
Yes.
So this is a basic circuit which I have drawn with respect to an ammeter and a battery. Okay, fine. First and foremost, how does current passes? Okay, how does the charges move? Okay, so that is defined as current. Current is defined as how many charges, okay, will move across the conductor. How many charges will move across the conductor in a circuit for 1 second.
Okay.
Any charges move across the conductor in a circuit for 1 second. So that is defined as current. And here the charges are represented by the symbol capital Q. Remember that.
Okay.
And time is represented by time only. T, small t is represented by time. So I is equal to Q by T is the formula. I is equal to Q by 2 is the formula.
Yes.
Understanding?
Yes.
What did I tell you? How many charges will flow? In terms of physics, formula and all, how many charges means how many Q flows with respect to time. That is okay. This is with respect to the formula, the symbol, and its notification. Next is current. What is current? How do you define current with respect to SI unit? Very important. Okay. So current is defined as, the SI unit for current is ampere. Remember that. Okay. Very important notations. SI unit for current is ampere. SI unit for charge is what? Coulomb. SI unit for time is what? Seconds. So therefore 1 ampere is equal to 1 coulomb by 1 second. I've just substituted in place of I 1 ampere, in place of charge 1 coulomb, in place of time 1 second. So this is 1 ampere. Understanding?
Yes.
I'm just not just giving a hint. How does the current moves, or how does the formula works? Okay. Very important point here is that students will usually get confused with respect to the symbol and the SI units. Okay, symbol is I, SI unit is ampere. Symbol is Q, SI unit for SI unit coulomb. Symbol is time, SI unit is second. Understanding?
Yes.
Okay. So fine. I told the charges will move from this end to this end. But what makes the charge to move? See, for instance, I have this pen here. I want to move this pen. What makes this pen to move from this position to that position?
The work done by the user.
Very good. So work should be done, isn't it? But then is what? You are giving some force for the body to get displaced, isn't it? You're giving some
force.
See, if you keep a body here, a box here, okay, you are pushing it, isn't it? So force, it gets displaced like this. Okay.
A,
B. Okay. This displacement will lead to what? Work done. Force into displacement. But fine. Here, how the charges move? They should have some force, right? Isn't it? So you will be having the cell. So inside a cell, what you will be having? You will be having the chemical inside that cell, the cadmium and all, lead, zinc, cadmium and all. So what you're doing, you're giving a force for that chemical to move.
Yeah.
That force is called as EMF. Okay, EMF, internal EMF, voltage, potential difference. All these three mean one and the same. Okay? A force is applied. So here if you observe voltage or potential difference, how much work you are doing, okay, how much work is done for these charges to move from this position to this position. Always the charges move from higher